Lesson 5, Sketching Graphs. So we have a graph that shows the number of fishing boats anchored in an inlet in Queen Charlotte Islands on a function of time. So first things first, you need to decide which is independent and which is dependent. And we know that time is independent. So that means that number of boats depends on what time it is. So that means that we're going to use our independent on our x-axis. And we always put our independent on our x-axis. And our x-axis is the horizontal x-axis. X-axis, yeah. So our y-axis goes up and down. So we're going to label this time. And we need to choose a scale that is appropriate to the size. So scales that are good are 1, 2, 5, 10, 25, 100, 50 is good, 0.5 is good, 0.2 is good. So something in those range, because it looks better on the graph. So we're going to start with 9. So we're going to take out a little piece of the graph, and when you have a squiggle like that at the beginning of the graph, that means that you've omitted part of the graph because you didn't find it necessary. So we're just going to start at 9. 10, 11, 12, 13, 14, 15, 16, and 17. So I only wrote in every other number so that it would be less congested down at the bottom. Now we're going to do our y-axis. So this is our number of boats. So we're going to choose a scale that is appropriate. So we're going to go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Now you're going to plot each point. So for the first one, at 9 o'clock we have 25 boats. So that would be right here between 24 and 26, right on the line. At 10 o'clock we have 10 boats. Oh, I put that in the wrong spot. That's why it looks silly. So a good way to make sure you've lined things up properly is to use a ruler as a guide. At 11 o'clock, there's 8 boats. At 12 o'clock, there's 6 boats. At 13, there's 6. At 14, there's 10. At 15, there's 11. And at 16, there's 15. Now, question asks, will we connect the lines? The only time that you connect the line is if you can hit every point between the lines. So what a line really is it's like a bunch of little points getting hit all across the way. So if you had a line between these 2 points, don't draw this in, that would mean that even right here, you could have a point. Right here, you could have a point. Every single point is hit. If we hit right here, between 15 and 16, that would mean you'd have to hit half of a boat. Can you have half of a boat? No, you can't have half a boat. So you can't actually have every point between these points. You can only hit the red dots. So no, because you can't have half a boat. A good way to remember it would be is if you can have a decimal. Can't have decimal. Good. Question 2 is about a wave. So it's the height of a wave. So our independent is going to be time again, and our dependent is the height. So this is our time, and this is our height. And we're measuring the height in meters. So our times are the same as the last graph, so we can use the same thing. So 9, 10, 11, 12, 13, 14, 15, 16, 17. Our heights start at 0.9 and they go all the way to 0.5. So we're going to go up by 0.2s. So 0.2, 0.4, 0.6, 0.8. I'll just write them all in. This will be 1.0, 1.2, 1.4, 1.6, and 1.8. This would be 2. So we're going to plot the points. So at 9 o'clock it's at 0.9. That's right about there. At 10 o'clock it's at 1.2. At 11 o'clock it's at 1.4. 12 o'clock it's at 1.5. 13's at 1.5. 14's at 1.4. 15's at 1.2, and 16 is at 0.9 again. Now, we need to know if we would connect the dots. I didn't even finish writing this word up here. Anyways, so the point here is that if we connect these dots, that would mean it would have to hit every single height in between. Could you go from 0.2 centimeters all the way to 0.8 centimeters without hitting 0.4 and 0.6 and everything in between? No, because at some point in time, it might be a very short period of time, it had to hit every single decimal in between because it was rising up to that point. So because you can have a decimal for this one, you will connect the dots, because you'll hit every point. Okay, the next examples. We have a graph and it's the function of negative 3x plus 7. So that's this line. Right here, that's the function. So what we're going to do is we're going to determine a couple values from this. So we want to find the range value when the domain is equal to negative 2. So domain is your x values. So our x-intercept is horizontal, and our x-axis, and our y-axis is vertical. So we don't see them. Here they are. That looks bad. There we go. Still did the same thing. Okay. So that means that our x value is at negative 2. So we're going to go down to negative 2, which is right here. We're going to go up to the line to see where it crosses our function. So our range value is our y value. So that would be at 13. So the range, which is the y, is equal to 13. For b, our range is 4. So we're going to go up because that means it's our y value. So at 4, we're going to see where it crosses the function. And it crosses when x is equal to 1. For C, we want to find f of negative 3. And this has replaced our x. So we know x is negative 3. So we go all the way to negative 3. Oops. Up to where it crosses. And it's at 16. So y is equal to 16. And the last one, D, f of x is equal to 7. That means that's our range. Our y value is 7. So we go up to 7, which is right there. So x is equal to 0. And a way that you could solve for it, if you're not sure from just looking to the graphs, is to plug all the information into the equation.